Welcome back to the RetroRemakes project in Unity. In this video we will take a closer look at the third game of the project, the game Oli Tycoon. Since the game is a bit more complex, I will split the introduction into 3 parts. In the first part here we will take a closer look at the general building of the scene. The specialty of this game is that it consists only of UI elements, so there's not much going on in the 3D environment of Unity, but everything is handled in the UI. And the second thing is we have only one scene, despite the game being a bit more complex. You can find the scene in the Scenes folder, Oli Tycoon, and the scene Oli Tycoon. Make sure to set the aspect ratio to 640 by 400. And as you can see, we have our main camera, the main cameras with the UI, the event handler for the UI, and the game manager. And the interesting part is, of course, in the canvas. Here you can see a bunch of screen objects. These are basically just panels in the UI. So just normal game objects with an image component. And every panel object here in the hierarchy also has a fitting script on it. So for example, the title screen has a script title screen, the office screen has a script office screen, and so on. All these screen scripts are derived from a base screen script, so they all share a similar behavior. Each screen represents a context in the game, for example, the setup or the office screen where the player can conduct their business from, or the end of round screen. So basically they are just different sections in the game. Each script for those screens encapsulates all functionality for that screen and also references to all components the screen needs. For example, here the title screen has just one button to start the game, and as you can see, the onClick function has title screen show setup screen. So most of the time when you find buttons or functions you can execute in the screen, the code behind these functions is to be found in the according script. The different screens are shown to the player just by activating the game object for the screen. For example, when we want to go to the office screen, this game object gets activated and automatically the screen that was opened before gets closed. That has 2 simple reasons. For one, we don't have to bother in which order we arrange our screens. So when you open the office screen, you can be sure that the office screen is always visible and not hidden behind another screen in the hierarchy we left open. The other reason is performance related. Whenever an UI element changes, for example, when we assign a new text or an image to an element, the whole canvas in which this element resides gets rendered again. So if you have many things active in your canvas and you change one tiny little thing, everything needs to be re-rendered. And this is also true for objects that you can't even see. For example, let's make a test. This office screen and the title screen have 446 triangles. And when we open the computer screen, that is completely covering everything, then we have 578 triangles, but they are not coming from the computer screen, but also from the office screen. And when we deactivate the office screen, we only have 210 triangles. So instead of leaving everything open, we keep things nice and tidy, so the triangles are only rendered for the things we need to see. Let's close that screen again. There are a few different philosophies when it comes to organizing an UI. One you can see here, everything is under one canvas and you can activate and deactivate objects you need. The other method is you can split your UI in different canvases and they can exist beside each other, or you can put canvases under canvases. And by that you make sure that only a canvas that is affected by a change gets re-rendered. And the third method is that you can even take single objects from the UI out of here and put them into a new scene. And whenever you need that object, you load the scene additionally to the main scene. For example, we could have put the computer screen in a scene here, and when we want to show the computer screen, we load that scene additionally. It gets inserted additionally to our main scene, and the computer screen is shown. That has the advantage that the main scene is very clean, and only objects that you really need are loaded into the scene. For this small game, neither of those give us a significant advantage, and my personal preference is to keep everything together so I can see what's in here, and I can also test very quickly a single screen by just activating it and working in it instead of having to load it additionally. But it is surely good to know, especially the performance issue, and there's a guide for Unity that explain these issues in more depth, and I will put a link to that in the description of the video. Like mentioned earlier, each screen has the functionality it uses in their own script, and additionally to that, the children of each screen also consist of everything that is seen in the screen. For example, here we have the office image in the background, or we have a bar of buttons on the left side, 3 buttons we can click on, and again the functionality office screen show briefcase window. That should happen when we click on that button, and that is contained in the office screen script. Each script also has the references it needs to know about. For example, here in the office screen, it needs to know about the office image, because when another player takes their turn, then maybe they have chosen another image for the office, and so the screen will change the background image accordingly. Besides those normal components like image or buttons, you can also see we have window objects here. And some screens have only one of those or no window object at all, and the office screen has a few of those. And they are very similar in concept to the screens in that regard that, for example, the briefcase window has a briefcase window script, and the balance window has a balance window script, and so on. And they also have references to the components they need to know about, and also the functionality that is used in the window. Let's say, for example, the agent window, where we can hire an agent and execute sabotages on your fellow players. You have an up and down button and OK to confirm, and this functionality is also contained in this window script, in that agent window script here. So let's, for example, try this out. Here you can see I can cycle through the several agents, and when I'm deciding on that agent, I can see what the costs and duration of this contract are, and then I can confirm with OK. Let's take a small peek into the code to make this more clear. We will take an extensive look in the code in the following videos. Here you can see the Text Mesh Pro references to the text fields in the window. The window also manages its own variables, like what agent we have selected. Then the up and down functions call these functions, and this just increases or decreases the selected agent number, and then calls render. And the render method fills the text field with the data for the selected agent. And when we click OK, the confirm function is called, and besides a few other things we will take a look at in a minute, the close function is called and the window is closed. You won't find the close function here directly, but in the base class of window. Like for the screens, all windows derive from a window base class that provides basic functions like showing or closing the window. Let's minimize that window again and close this window again. Windows are opened and closed with the help of the UI manager. For example, let's take a look at the Office screen and the Files button. That is this button with the briefcase. When we click on that button, the Office screen Show Briefcase window is called. So let's just open the Office screen script. Here you can see Show Briefcase window function, and all that does is asking the UI manager to get us the briefcase window and calling show on it. In contrast to the screens, you can have multiple open windows, so the old window is not closed automatically when you open a new window. Just to reiterate on those concepts we learned so far, let's open the computer screen. Here you can see it has a computer screen script and it also has windows. Let's activate one, and that by window has a by window script, and in that by window there are a few buttons, for example by oil field button, and by oil field button just calls by oil field from the by window script that is sitting on this game object here. There are some screens that are used in different contexts, and what that means, let's take a look at the world map screen. Here you have an overview of the world map and different regions, and this screen changes its functionality depending on where we arrive from. For example, in the Office screen we can click on the world map and then the world map screen gets opened, but in a mode that when we click on a region and explore the sectors in that region, we will just see who the sector belongs to, but we can't do anything else. In contrast, when we arrive from the computer screen by clicking the By Oil Field button, then the same screen gets opened and we can explore the regions and the sectors, and when we click on a sector, we will be able to buy an oil field. And in the same manner, we can use that screen to get an expertise. And when we open the screen in that mode, a click on a map sector will show an expertise for that map sector, but it will not buy an oil field. So the world map screen has different modes that can be set in the code before it is shown. And the world map screen, once it opens, knows what to do in that mode. The same idea of reusing screens is also applicable to windows. For example, let us start the game in the Office screen. When we are checking for phone calls, for example, we will get a message window. It tells us no calls received yet. And it displays our logo of our company and an icon depending on the type of message we get. This is a warning, for example, but we can also have different icons here. So as you can imagine, there are many places in the game where messages are shown to the player, and one possibility would be to make a window for each of those messages. So this window would be called sorry, no calls received yet message window, but that would be a waste because all message windows have the same functionality and only are differentiated by the message and the icon they show to the player. In any case, when we press OK, the window is closed. So let's take a closer look at that message window. As expected, the message window has a message window script and has references to the icon of the window and also to the displayed message text. Let's show the window again. Here you have the message text and here the image of the icon. So similarly to the world map screen, it would be great if we could configure this message window in different modes. And in fact, you can do that. You can just get the window from the UI manager, and you can set the text you want to show to the player and the icon, and then you can call show on that window. To get an idea how to do that, we will just take another short glimpse into the code. Here we get the message window script and the image and text mesh pro component. And here you have the two methods with which you can configure the content of the window. It's called with icon type and with message. And if you use with message before showing the window and give it a string as a message, then the window will put the message in its own private variable. And when the window is shown and gets rendered, then the text mesh pro component is updated with that message text. And that it's useful, you can see here, Rider, which is my IDE, shows this configuring method is called 20 times throughout the game. So at least 20 times we show that message window to the player for different messages. For example, let's revisit our agent window. When we click OK, this confirm function gets called, and in case the player already has hired an agent, then we will show the player a message that you can't hire another agent. And the message should be special agency is still working for you. And like shown a bit earlier with the briefcase window, we ask again the UI manager, please get me my message window. But before showing it, we call these functions with message and give this message to the window, and with icon type, and this is an enum. We can have 4 different icons right now. And then later on, the message window is shown with the show function. Don't be irritated by this on window closed and so on. We will take a closer look at that in a moment. Let's minimize it again and stop the game for now. The next UI object we have here in the scene I want to explain is the ticker. The ticker is a bit like the message window in that regard that you can set a text, but it is not showing as a window, but instead you will see a rolling ticker at the bottom of the screen. I can give you an example. So I'm clicking on the calendar to end my round prematurely. And here you can see a similar window to the message window. It's called question window. And the difference is it has 2 buttons this time. You can just click OK and close this, but you can decide what happens if you click yes and what happens if you click no. This is a bit more on the coding side, so we will take a closer look at that later on. For now, I want to finish my turn, and the next player also finishes their turn. Then the computer takes their turns. And here you can see the ticker running through. It's just a message scrolling from right to left, and the important part here is the background image, because it seems to be an endless image, or at least a very large image. And when you take a look in the scene view, we just see that the message is really long, but not the image. And the reason for that is that the message can be really, really long, and we don't want to waste any space for the image. So we use a very convenient trick. You can see when you advance the game frame by frame. It just scrolls the image to the left side until it reaches its end here. One more step to the left and the image would have ended. So the next step, we skip the image back and scroll it to the left 3 more times, skip it back, and so on. And if you watch the game window, it appears that no jump is happening at all, but that the image is an endless image. So let's continue here and end this screen to go back to the office screen. And when you experiment with the windows and open and close them and take a look what happens here in the hierarchy, You might notice one object that is jumping around in the hierarchy, and that is the Close Windows panel. The Close Windows panel is just another UI panel, and when a window gets opened, the Close Windows UI panel is automatically placed behind that freshly opened window. And the reason for that is that the Close Windows panel has a button that stretches over the whole screen. And on clicking it, the on-click Close Windows panel in the UI Manager is called. And that is working because we have set the image of that button as a raycast target. So when we click here, our mouse click will get detected by that panel, except when we click in the freshly opened window. Because in the hierarchy, it is in front of the panel. So every click we make on the window is caught by the window, and every click we make outside of that window is caught by the Close Windows panel. And the reason number one for that is you can see the briefcase window here has no OK or confirm or close button, so somehow we have to close that window again. And in that case, you can set the Close All Windows on Click Outside checkbox. And this means when the Close Windows panel detects the mouse click, it will automatically close all open windows. So to close this briefcase, we just click outside. The same happens here, for example, for the drawer window. Note that the Close Windows panel has hopped one step down directly above the drawer window. When we click outside, the window closes. And the other reason, when we open our agent window again, notice in the hierarchy, Close Windows panel is behind it. This window has its own OK button, so we can close it using OK here. And we can close it by clicking outside. But the Close Windows panel is useful nonetheless, because we have buttons here in the background. And if we don't have this Close Windows panel that catches our mouse clicks outside of the main window, then we would be able to click those buttons in the background. And that is not a desirable behavior to open other windows over that window. The panel also has the side effect of darkening the background a bit, so the currently opened window is a bit more visible. You can see it here, the image has a black color and the alpha value is set to 30%. If we raise it, you can see what that does. The follow-up window here, and when we close it, you can see the main screen in full brightness again. This will help guide the player at what the active window is. Down here you will also find another special object beside the Close Windows panel. It's the black panel, and that is just useful for fading between screens. When you want to go to another screen, the UI Manager has a function for that. It's called Transition to Screen, and you tell the UI Manager which screen to fade to. And then on the transition, the UI Manager will fade in this black panel by raising the alpha value of that image. Then the new screen is activated, the old one is deactivated, and then the alpha value gets decreased again so that the black panel is no longer visible. For example, when we transition to the map screen, you can see here the alpha value is animated. And you can see here in the game view how this fading effect looks. Let's take a quick look at the UI Manager. It is sitting on the canvas object, and it has mostly internal functions that we will take a look at in another coding video. But the things that are exposed here are the ticker that can start, or the black panel for fading, and the Close Windows panel it needs to know about when a new window gets opened, so it can be moved accordingly in the hierarchy. And it also has a list of icon type sprites. We have seen when configuring the message window, we can also set an icon type, and this icon type is an enumeration. And we have 4 different types at the moment: an exclamation, no money, question and attention, and here you can configure what icon to use. For example, we have seen the warning icon, and when we configure the message window with a question icon, then this icon here is used. Earlier I said that new windows are just opened by activating the game object and deactivating on close, but in reality it's a bit more complicated. Let's take a look at the start of the game. First we come to the setup screen, and when we open this up you can see there are a number of windows that get opened after each other. So first we have to enter the number of players, then the name, they can choose a company and so on. And showing this window just by activating and deactivating it is not really a problem, but you may have noticed that each window has a fading in and fading out effect. For example, it fades small, it fades big again, fades out, fades in. And the fading itself is also not a big problem. It's just adding a rect mask 2D component, and then, for example, here in the player company window, you can animate this value to achieve this fading effect. But what makes it a bit more complicated is that the next window should only fade in when the old window is completely faded out. So you can notice when this window is fading out completely, only then the fade in of the next window starts. So we need a way of knowing when the fading of one window finishes. And for that reason, I introduced life cycle events to each window. These are just simple Unity events you will recognize from the buttons, for example, where you can add an action. And since each window derives from the base window class we implemented, the base window class has these 4 events. So every window that derives from the base class also has these events. And I called them lifecycle events before because they are scattered throughout the life cycle of a window. On before show means before the window is faded in. On window shown means when the window is completely faded in and visible. Then this event is thrown automatically by the window. On before window closed is triggered when the window should be closed but has not yet started fading out. And on window closed means the window has completely faded out. And you can use these events to add functionality at a certain time of the life of the window. An example I can show you. For example, here in the office screen, we have the drawer window, and here you can click on balance. So this window gets opened where you can see how many wells you have, how many tanks and so on. And we want this window always to open with the first tab where we can see our wells open. So no matter what the player has done last time they opened the window, for example, they have selected the contract tab and then closed the window by clicking outside. When we open the window up again, we want to show the wells tab selected. So you can see we are using on before show. Before the fading starts, we call show wells tab function on that window. Then the first tab gets enabled in the code, and then the fading starts. You can also use, for example, on window shown when you want to play a sound effect when the window is shown completely, and so on. But most of the time where we use these events is in the code. And to go back to our earlier example of the agent window, we said when pressing OK, the confirm function gets called. Then the message window is configured with that message in case we already have hired an agent, and the window is shown, but not immediately. Instead, we use the on window closed event and add a listener. That is what you can basically do in the inspector by clicking on the plus sign of the event. And we tell this event to execute that function we want to show the message window once we close ourselves the agent window. And when it closes, then the fade out animation gets triggered, and after that the on window closed event is triggered, and that calls the message window.show. So when the agent window is completely closed, then the warning window will appear. Let's close this. And it is personal preference, I think. I like to do most things in the code, but you would certainly be able to do it in the UI. Let's close those up and also the office screen. And when we take a look in the setup screen and the player number window, we know the next window after that should be the player name window where we input our name. So we could configure that in the inspector by saying on window closed and drag this window in here, and then looking for the script player name window and call show. So this would mean when this window closes, then the on window closed event is triggered and this function is executed and the next window is shown. What you now have to change, of course, is the function of the OK button. Let's take a look at that script for a minute. So here we have the confirm that gets executed when we press the OK button, and you would have to remove this line because this really is that what you have done now in the inspector, so we don't need it here anymore. But of course you need to create a new player and close this window. These functions you need to keep in here, and this style might suit your workflow or how you prefer to work in Unity a bit better. The only downside is that you can't configure the window that is shown next. For example, here in the agent window, you can do that in the inspector. You can say, show me the message window, but you can't tell the message window what message to display. You can of course make the method for setting the content in the message window public and also add that in the inspector. But since the parameter type of methods you can call are very limited in the inspector, you wouldn't be able to do that to set the icon in the message window, for example. And using the inspector is also a bit more inflexible because you can't make these actions depending on a certain game state. For example, the next window you want to show depends on the amount of money the player has. If the money is negative, then window A should be shown, otherwise window B. That is only possible to do it in code when the game is running. So that is the first part of the overview. I think it's quite complex and may sound a bit confusing, so I encourage you to play around with the game and see when you click on certain screens or on certain buttons what happens here in the hierarchy, and explore the scripts behind it a bit. We will take a closer look, of course, in another video. If you have any more questions about the structure of that scene, please let me know in the comments. I know it's a bit more complicated than the other games, so I'm not sure that I've covered everything. So please ask or come to the Discord and discuss the game there. But I think by experimenting with it, you will also learn a lot about the interplay between the different components here. In part 2 of the introduction for Oli Tycoon, we will take a closer look at two special screens. Those two contain the mini games of Oli Tycoon, one for drilling for oil and one for laying pipelines. There's a bit more content in those, so I decided to split them out into a separate part. I hope to see you there. Until then, happy creating and take care.